In example 3, we're identifying our end behavior of the linear functions. We look at it says describe and compare the end behavior of each linear function. So we're looking at the f of x equation. We look at the f of x equation. So remember, to the left, those are negative x values. To the right, we are positive x values. So it says as x decreases, we're going to the left negatively. F of x, remember, f of x represents the y values. It's increasing. It increases. As x gets more negatively, the y values get more positively. Then as the x's get more positively, our y's are decreasing. F of x will be decreases. So as x goes to negative infinity, f of x goes to positive infinity. And as x goes to infinity, f of x goes to negative infinity. When we look at the g of x equation, again, left and right, it says as x decreases or increases, the g of x, that means the y value stayed at 2. So as x goes to negative infinity, the g of x is 2. As the x goes to positive infinity, g of x is also 2. The line runs parallel to the x-axis. So there is no movement or change. It stays as is. In the checkpoint, it wants us to use the graph to describe the end behavior of the function. So again, we're looking at our x's. To the left, so as x decreases, f of x decreases. As x increases, f of x increases. So we write it, when we write it in notation format, as x goes to negative infinity, f of x goes to negative infinity. As x goes to positive infinity, f of x goes to positive infinity. In example 4, they want us to find the end behavior of nonlinear functions, which means they are our curved graphs, our curvature ones. So when we look at our end behavior here, as you move left or right, notice as we're going x to the left and x to the right, negative and positively, notice that our graph is opening up. So f of x is always going to increase in this format. So as x goes to negative infinity, the f of x goes to positive infinity. As x goes to positive infinity, f of x goes to positive infinity. On the g of x equation, notice as x goes negatively, y goes negatively. So as x goes to negative infinity, g of x goes to negative infinity. As x goes to positive infinity, the y goes to positive infinity. So as x goes to infinity, g of x goes to positive infinity. In example 5, it's talking about drones. So it says the graph shows the altitude of a drone above the ground, f of x, after x minutes. Describe the end behavior of f of x and interpret it in the context of the situation. So we have, it says the drone above the ground, f of x, after x minutes. So it says since the drone cannot travel for a negative amount of time, the function is not defined when x is less than 0. When x is less than 0. Remember, time is a unit of measurement. It cannot be negative. So there is no end behavior as x goes to negative infinity. Now, when we look at our graph, notice it keeps increasing. There's an arrow pointing up. So as x goes to positive infinity, f of x goes to positive infinity. The drone is expected to continue to fly higher.